Okay, so we are ready to code our binary search algorithm. To get started, let's go ahead and create a method called binary search. It's going to return an integer, and we're calling it binary search, which accepts an array of integers, and we'll call that A, and the value that we're searching for, that's our next parameter, and that'll be X. To cease this complaining, I will return the value of -1, which is going to be what's going to happen if we don't find what we're searching for, and that'll be the last line. Now, the first thing we're going to do is to initialize the variable P. But before I even do that, why don't I go ahead and add in some comments so we could keep track of the variables that we're using. I'll just go ahead and paste that in. So as you remember, A is going to stand for the array, X is what we are searching for, P is going to represent the first index position, Q the midpoint, and R the last index position. So let's do this in steps that we reviewed. Now, right off the bat, returning -1, if you recall our pseudocode, this was step 3, indicating that we didn't find the value that we're searching for. Step 1 will be initializing some of our variables. And I'll indicate for step 3, indicate nothing found. So the first that we could initialize is P, and that will be to equal 0. The beginning of the range. And I'll add in some comments so we can make sure that we're keeping track of what everything means. I know for me, it could get really confusing when we're just using some short single letter variables. The next thing will be to initialize R, and that will be to indicate the end of the range, essentially the last slot of the array. And so that has to equal length minus 1. We need some more realty, so I'll unpin the Solution Explorer. Okay, next is our while loop. And so for step 2, we do something. And that something is essentially searching for our value. So let's write it out. We mentioned that the condition is while P is less than or equal to R, we're going to assign the value of Q, and this is where I was saying the order of operations is important, P plus R divided by 2. And that is to find the midpoint. And just keep in mind that while we're in the loop, we are still in the range. Our next step is to check if X is less than our array with the index of Q. If that is the case, then R is equal to Q minus 1. And that is just setting R to be the midpoint. We're narrowing down to the first half of the array in the case where X is less than the data in slot Q. Let me just paste in my comments here. Now, if that is not the case, we can put in our else condition. Else, if X is greater than our array, the index of Q, then we can say that P is equal to Q plus 1. And actually, just to clean this up, I could get rid of these parentheses here. So let's do that just so that's a little cleaner. And essentially, what's happening here is the opposite of what happened on line 29. Here we bring P to the right of the array. And if we're still in here, then we have found our value. So we return Q. And of course, if we exited the loop, we return -1. And that is it. Now to actually execute it, let's create an array, populate it, and call our function. I'll say that the value that we're going to search for is 43, and that we're going to have an array of integers. We'll call this array over here in our main method. I'll just paste in some values. And then I'll write out to the console what our array contains, and I'll use our array class. Let's see here, capital A. This is built into the .NET framework. This array class here provides a nice little function that I can just pass in our array and use some lambda to just print it out to the screen. So I'm passing in the array and essentially just going to write out the content to the console. That's all that is, nothing fancy. But the important part for us here is to write out the result of our binary search. And so I will say that after adding a couple of new lines, the result of a binary search for our value is, and then we now call our function, the good stuff. Binary search, and we'll pass in the array along with the value of 43, and we're ready to execute it now. So let's go ahead and run this, save, Control F5. Our array contains 11, 22, 43, 54, and so forth. And the result of the binary search for 43 is 2, which makes great sense because the index of the array starts with 0, and 22 would be 1, and 43 would be 2, which is exactly what we get. This is extremely efficient because we are not going through every item to find a particular value. And it's also the reason why it's so popular.